Hello and welcome back to another interview at the Hero and Apta side event happening alongside the Future Blockchain Summit Dubai 2024. I'm Adel, the host, and I'm here with Brandon Crosbie, who is a data engineer. Is that right?
Yes, exactly. I'm the director of data engineering at Hero, which basically means I'm doing a lot of the lead data engineering development, as well as overseeing a lot of the process of how the data gets funneled into our AI pipelines and down to the granular level of making sure everything is actually accurate.
Fantastic. Let's begin with a warm-up question. In terms of AI, since you're working with it and you are an AI company, where do you think we are at in terms of the adoption curve? On the adoption curve, where do you think we're at? We're at the high end, the low end. Where do you think we're at?
So I think we're climbing up to the high adoption curve with AI at this point. So I would say it's been kind of about half a decade or more at this point where these terms like machine learning, data science, AI have been creeping into more of the corporate lingo rather than just a very niche kind of, subgroup of people that are experts. And I think we're at the point where, people may or may not be ready to jump into a car that's self-driving. But I think really what we're at is people are very interested to see what ChatGPT has to offer. And the people behind the scenes, like Apta and what Hero does, is we're basically doing damage control of what the popularity of something like ChatGPT allows people to think is ready to solve for them when they really don't understand that these generic results that come out of a LLM that's not properly fine-tuned are just inaccurate. So I think because it's too easy to use in some senses, it's creating more of this opportunity for us to rise above what a generic sort of solution gives you. But it also, we have the benefit of that kind of challenge already being solved, that people at least know what it is.
Yeah, I would agree because, people as young as 18-year-olds and even younger are using ChatGPT on a day-to-day basis to solve their homework, to do it for them. And we never had this at our age, right?
We did, if you knew where to go. No.
Oh my God.
So I would say, even I actually used to be a former teacher as well, from the level of teaching English to very young learners to, while I was in college, actually teaching electromagnetism. And at every level, you're going to find the type of student that wants the quick and easiest way to solve something, which isn't always an issue. It's more of just, you want to make sure they understand what they're using the tool for. So right now what you're having is a lot of the younger generation, they see that they can just solve the answer quickly by typing it into ChatGPT, and then they don't even go to the full length of removing the insert name, insert company here. And so you can kind of see how we're getting ahead of ourselves in adopting this rather than teaching people what it's useful for in terms of generating something that eases the amount of workload that people do, rather than just being the cut and paste solution to everything and then just trusting that it's true when it's typically there's a lot more that goes into finding out what's actually accurate.
Now, as a data engineer, you must be this must be right well down your alley, quantum computing. The topic of quantum computing must be the next level of computation, and also like getting data, more useful data for making more informed decisions. So as I understand it, when you're flipping heads or tails, right, you're not just getting the heads or tails result. You're getting everything in between heads and or tails. So that's just a very minor way of explaining it. But for the audience, how is quantum computing really helping in your field of work?
So I actually had to make a business case presentation on how quantum networking and quantum computing could be actually practically used about 7 years ago at this point. And so I did a little bit of research at the time, what was actually useful. And I think what you're getting at with the sort of theoretical probability is true here. When you flip a coin, you can't possibly tell whether, because it was heads 6 times in a row, that it won't be heads again. That has nothing to do with what the probability tells you. It's just a matter of maybe that is, we know because of some calculations we can run. When it comes to something like quantum computing, we're still at the state where it is way too expensive to practically use on a grand scale because of how much cooling you need, how much very niche expert engineering and PhD talent you need to put everything together just to add 2 numbers. Right. And so, yes, we can prove these kind of one-off cases with something like a quantum computer, but I think the more practical understanding of what what we can glean from this is that when you're using something like a quantum computer, you have the ability to measure like the spin of an electron. And so what that allows you to do is truly generate something that's a random number. And if you understand what benefit that gives you, you kind of understand the world of what actually, how this crosses into blockchain, cryptology, generating hashes and blocks. It's actually the same fundamentals. So when you're measuring the spin of an electron at a given point, you actually change the outcome of what it would have been if you did not measure it. That's the entire Pandora, no, not Pandora's box, Schrodinger's cat. That's the entire idea. Like, is the cat dead or not? You don't know until you open the box. Once you've measured, opened the box and viewed it, you've now changed the outcome of whether that cat was dead or not. So it's actually the same principle within the fundamentals of just cybersecurity, is if you can apply that same kind of understanding of this electron was measured at this date and time, and that actually changed an outcome. If you didn't expect it to be measured at that date and time, you have a different sort of metric or performance at the other end of it. So, if, kind of to summarize what my presentation was 7 years ago, I'm kind of summarizing it as I can remember it. But the idea of something that's extremely secure is typically built off of random number generators that have private and public keys. And if you have some sort of, malicious actor that's going in between, the Alice and Bob sort of cybersecurity situation, you can actually see something changed here that I didn't expect because someone just viewed this. Someone just looked at my data payload going back and forth. And then you can see, okay, the suspicious activity is at play here because that measurement changed the entire outcome of what was already expected. So that, in a nutshell, is how quantum computing today is already practical. However, scaling that up and trying to match what, the sort of the binary computer 0 to 1 sort of system that we have in place it's not going to be matched anytime soon. But there's an interesting sort of thing I can summarize with one of the highest level electromagnetic sort of founders of the space, Oliver Heaviside. His entire dedication to science was the understanding of the step function. And it's interesting to understand that 0 to 1. What happens between 0 and 1? Literal infinite number of decimals happen between 0 and 1 to make all those sort of random sort of numbers and understanding of just that quick behavior. And it's called the step function.
The step function.
Yep. So that ties into anything that happens between just bit switches of transistors and understanding at the quantum level, building that into a network. Because everything happens at the quantum level in some capacity, especially with transistors. So that's a huge topic to keep going into, but I think I've already rambled enough.
No, that's really good. I think this is a very interesting topic. I would love to go down the rabbit hole, but I think we have enough information there for a side event interview, and would love to take it further on a more podcast level kind of interview. But I do want to thank you for your time. Appreciate it.
Thank you so much.
Thank you for being thank you so much for watching. Hope you found this very insightful, and we'll leave all the links in the description so you can check out Brandon's profile as well as Hero and Apta. But thank you again, and we will see you next time. Thank you so much. Cheers.